the next one, FOV. So what is FOV? FOV means field of view. Field of view. In Chinese, it's called 视场角. In Chinese, it's called 视场角. Alright, so what's the definition for that? Let's take a look. If you are talking about the frame camera, if you are talking about the FOV for a frame camera, the FOV is the angle, it is the intersection angle between the diagonal we can say location. So let me draw it actually. Okay, so imagine right now you have an image plane over here, and you have a perspective center. Right, so the FOV is this angle. The FOV is this angle. So which indicates this diagonal line over here. So so in terms of a frame camera, the FOV is defined like that. So it's the diagonal FOV. So for these 2 points, and then you have the perspective center over here. And what's the angle of that? That is usually called FOV. Okay, so for the frame camera. And so write it down over here. And however, for the push-pull scanner, as you can see, the push-pull scanner is right now it is written as field of view across track. So which means that if you are having the the push-pull scanner, then in this case, what you have over here is a 60 array and a 60 array. And in this case, the field of view that you are talking about is this intersection angle. And you have a flying trajectory. Okay, you have a flight trajectory. So in this case, this is the across track. Across track FOV. Right, across track FOV. Alright, so let me just try to describe it again. So if you have a push-pull scanner, and then this is your flight direction, and this is your CCD array. So you are scanning through each of the line on the ground. So the FOV, so you have two terms. One is along track, along your track, and the other one is across track, right, across track. So in this case, the FOV for the push-pull scanner is the across track FOV, right? It's the across track FOV. So which is if you have the the perspective center over here, then from this point to the two ends of your CCD array, that's your across track FOV, right? So that's this. And in terms of front camera, we usually talk about the FOV as the diagonal FOV. Okay, so as you can see, field of view diagonal is, for example, in this case, is 90 degrees, right? And of course, for the front camera, you can still and also calculate the across track FOV or also the along track FOV. So you can also calculate that. And sometimes people will also use this term as well. Okay, so remember that. Okay, so in terms of the coverage between these two, it's actually pretty much it's just a definition. The term are different. So if we are talking about the analog age, the term to describe the coverage of the image is usually called full frame. so as you can see, for this case, the footprint is like 2.4 kilometer by 2.4 kilometer. So that's the for the analog camera, and for the analog frame camera. But however, if you are talking about the digital push-button scanner, and then in this case, the coverage of the image is usually called swath. Swath. In Chinese, it's called 相幅宽. Swath. Okay, so as you can see, that indicates the length of your cross-track scanning area. So in this case, the swath is 2.4 kilometers. So which means that every time when you are flying at a different time point, you are scanning this 2.4 by kilometer range. So that's the swath. Okay. And then the next thing is about the scale, or you can say kind of like the spatial resolution that we talked about yesterday. So in terms of the scale, for the analog age, usually we will call it scale, photo scale. So scale. If you are looking for the Chinese term. Alright, so photo scale. So I believe you guys know it. The photo scale is like 1 to how many? So that's the scale of your image. And on the other hand, if you are talking about the digital camera, then the scale of your image is usually represented as the ground sample distance, the GSD that we talked about before. The ground sample distance, right? The ground sample distance, which represent the spatial resolution that you know of actually. So for 1 pixel, and then what's the size if you project it to the ground, and what's the pixel on the ground. So in this case, it's 20 by 20 centimeter. So that's the GSD, ground sample distance. Okay. Okay. So should be easy to understand. The last thing that I want to share with you is the other term, which is called Alright, so the other thing that I want to share with you is a new term, which is called IFOV. Which is called IFOV, instantaneous FOV. So in Chinese, it is called 瞬时市场角, instantaneous FOV, called 瞬时市场角. Alright, so the definition for that is the instantaneous FOV is the FOV for only one pixel. The FOV for one pixel. FOV for one pixel. And usually when you are talking about the instantaneous FOV, we will just calculate the across track or a long track, doesn't matter. We won't calculate the diagonal FOV for that small pixel. So we won't do that because that doesn't really change too much. Okay, that doesn't really change too much. So basically the calculation is like this. You could calculate it according to these two equations. The first one is if you have the CCD size, and like this, then you can divide it by the focal length, and that's the instantaneous FOV. So pretty much it's like you can say if you know one FOV, one pixel over here, then what you can do is you can calculate this. Like that. So if you know one CCD sensor size, and then you just divide it by the focal length, and then you can get the IFOV. Okay, so that's the case. Right, so that's one way to calculate it. And the other way to calculate it is you know right now the FOV, the entire FOV is how much, and then you just divide it by the number of pixels that you have. And then so yeah, you can have the IFOV as well. Okay. And as you can see, because the pixel is very small, so the IFOV is also very small as well. So in this case, you can say the unit of measurements that we use to describe the IFOV is not like degree, or it's not like second, or it's not like that. We usually represent the IFOV with the mini radians, MRAD, so mini radians. Radians, I believe, for those of you who know Chinese, it's called 进度量, or yeah, 进度量. Okay, so mini radians. Okay, okay, that's the case. Okay, these are some of the terms that I want to share with you guys. Any question for this? No? Fine. So that's pretty. Should be very easy to understand and to to understand. So before we start moving to a new topic, because Kunio just arrived, so we will let him decide which paper you are going to present. Originally, you are pretty, like, your priority is really high, but however, because you are late, so you will be the last one to decide the paper. Okay, so, which means you don't have too much choice. Let me take a look. 大家都选完了，对。谁叫你要迟到？ Okay, so you don't have too much choice actually. What's your first, your favorite paper that you want to present?
Original?
Yeah, original one. Maybe it has not been picked. One? Number one? 7? 7 is picked by someone who ran out. Alright, the only choice that you may have, I think, number 13. And in the first 5. first 5 and also the 17. Sorry, the first 5 and also 13. Right. First 4, actually, the first 4 and also the the image matching is actually the next topic that we are going to talk about today. Okay, so it's actually very important. So and a little bit difficult to understand, just a little bit. But these are the, you can say, more state-of-the-art development for in the image matching field. Okay? So we are going to introduce the general idea of image matching later. Okay? So what's your choice? The third one. Okay, it's here. The first one. Sift. Okay. Okay, so yeah, that's a good choice. This is the original paper proposed sift. 这个有吗？
是。
这个。Right. Yeah, this is a good choice. So law proposed SIFT in 2004, and then this solution has been used a lot, a lot nowadays. Okay, so in the past it's not very famous, but however nowadays it's like